Bismillahirrahmanirrahim. Assalamu alaikum and welcome back. In part C of our lecture on anthropometric design, we will discuss some anthropometric principles. And we will basically discuss three principles. The first principle is design for maximum dimensions. The second principle is design for minimum dimensions. The third principle is design for a range. And these first two principles are sometimes collectively called as design for extremes. And in the third principle, we will discuss two options to design for a range. First one is to make different sizes, that is to make the same product in different sizes. And the second is to design for adjustment. What is the basic idea? The basic idea is that the approach of ergonomics is to consider product dimensions in human terms. So that is the first point, that whatever product we are going to design, we have to relate the dimensions of that product with the relevant anthropometric dimensions. And secondly, in view of the constraints placed on the design by human size variability, human body size variability is also to be considered. So we discussed few examples in the last lecture, and we will solve an example of the design of interior of a car in the practice session today as well, where we will relate actually the different dimensions of a car interior with the human body dimensions. So we will see these two things there as well, that we have to relate the product dimensions to the human body dimensions, and for each dimension we have to see how we can actually cater for the body size variability. So in order to clarify the concept, let's take the example of a chair. Let's suppose an office chair. So there are different dimensions in the office chair that must be considered to design a chair. So you can see different dimensions are marked here. So once we have actually listed down these product dimensions, the second step is to relate these dimensions with the relevant human body dimensions, and then see how we can address the body size variability. So for example, this height h, that is called the seat height. So this has to be decided. So this seat height actually relates to which anthropometric variable? So this relates to popliteal height. So for the population for which we are going to design this office chair, we need the data of popliteal height. So this is one thing that we have done, that we have identified the product dimension, that is the seat height, and we have identified the anthropometric variable to which it relates, so that is the popliteal height. So the next question is, what should be this height h, seat height? Because there is a lot of variability in the popliteal height of the people in that population. So which value should we take? So the answer is, we have to identify the limiting user. The limiting user. The limiting user means which user or the user on which extreme will be actually affected if the design is not appropriate. And the answer is, in this case, in the case of seat height, the limiting user is the shorter user. So we will consider the shorter user to specify the seat height. So we will take the popliteal height of a shorter user to decide this height h. So suppose we decide the 5th percentile value of popliteal height in this population to decide the seat height h. So the idea is, if the shorter person can touch his feet on the ground, then it won't be a problem for a taller person. But if we do other way around, and if seat height h is decided according to, let's say, the larger percentile popliteal height, then people smaller than that percentile value won't be able to actually touch their feet on the ground. So it will be misfit for the majority of the people in that population. Let's take another example. That is of seat. That is the height of the seat back. That is height A. So this height of the seat back depends upon which anthropometric variable. So this depends upon the sitting height of the people in that population. So again, we have related this dimension of the product, that is the height of the seat back, to the relevant anthropometric variable, that is the sitting height of the people in that population. So the next question is, what will be the value of this height of the seat back? Because in these examples, actually, in the case of this sitting height or the height of the seat back, we have to make one product, and we have to specify a dimension of that part of the product, so that that product is suitable for majority of the people in that population. So the question again here is that what will be the height of this seat back? So which value of sitting height should we take? And in this case, the limiting user is the taller person. So if we make this height of this seat according to the taller person, then of course the shorter person can also easily touch their back with the back of the seat. But again, if we do other way around and this value is specified according to the sitting height of a shorter person, then say some part of the back of the taller person will be in air. He won't be able to touch his back with the chair. So that is the basic idea, that we have to first identify the dimensions of the product, relate relevant anthropometric variables to each dimension of the product, and then we have to find the limiting user for each dimension and specify the corresponding value. So whether it is going to be the smaller value, say 5th percentile, or the larger value, say 95th percentile. So that is the basic idea behind design for the extremes. So either we are going to design for the minimum, as in the case of seat height, or and we are going to design for the maximum, as in the case of the height of the seat back. So we have discussed this point already, that we have to decide either maximum or minimum dimension is to be considered. That is, a smaller percentile or larger percentile is to be considered. So in the case of design for the maximum dimensions, as we saw the example of feedback, a higher percentile value of an appropriate anthropometric dimension is chosen. So when designing a doorway, for example, sufficient headroom for very tall people has to be provided. So in this case, in the case of the height of a door, we have to consider a higher percentile value, say 95th or 99th percentile value. So if a taller person can walk through the gate or the door, the shorter user can easily pass as well. So the doorway should be no lower than this minimum value, this 95th or 99th value, and additional allowance would have to be made for the increase in stature caused by items of clothing such as heels of the shoes, cap, etc. Another example is seat breadth, that is the seat width. So here we have to specify the larger percentile value, because here again the limiting user is a heavier user. So we have to specify the larger percentile value. So in the case of doorway, the limiting user was the taller person. So larger percentile value was specified. So same is true about seat width. So here again the limiting user is heavier person, so larger percentile value is to be decided. So if a heavier person can sit in a chair, it won't be a problem for a leaner person in that population. So width of a seat must be no narrower than the largest sitting width in the target population. So we discussed this first example, the height of a doorway. So this should be according to the larger percentile value plus some clearance for shoes and cap, etc. And same principle actually applies to the width of the doorway. So that would also be according to the maximum dimension. So for the height, the limiting user is the taller person, and for the width, the limiting user is the heavier or bulky person in that population. So this width should be according to the a larger percentile value uh, in that population. So if a heavier person can pass through this gate, the leaner or the thin people can also pass. So both these are examples of designing for the maximum dimensions, that is specifying a larger percentile. We discussed this example of seat width as well. So the width of a chair must be no narrower than the sitting breadth of a large person. So if a large, so smaller person can also sit. In fact, that smaller person will have some clearance as well, some allowance as well. Another example is the toothbrush. So a toothbrush must be long enough to reach the back molars of someone with a deep mouth. So if that is done, then a person with a relatively shallow mouth would be having no problem to use the same toothbrush. Yet another example is this kneeling chair. So the distance from the knee pad to the back of the seat. So we are talking about this dimension, that is this one, this dimension from this knee pad to the back of the seat. So this must also be according to the larger percentile. So so that if a taller person can sit in this kneeling chair, that won't be a problem for a shorter person. So shorter person may have to say sit slightly uh, in the forward direction on the seat, but the ultimate goal is that this knee pad touches this point on the kneeling chair. So shorter person can easily adjust himself on this seat by sitting slightly in the forward position. But if it is made, this length that is indicated, if it is made according to the shorter person, then theoretically the taller person will need to sit somewhere over here, but there is no span of the seat in this position. So this will be misfit for the taller person. So again, the limiting user here is the taller person. So we have to specify this dimension according to the taller person. So if a taller person can sit, the shorter people or the people who are smaller than that percentile value can easily sit by simply adjusting themselves in this direction on this kneeling chair. And finally, the length of a wheel brace must provide sufficient leverage for a weak person to generate sufficient torque to loosen the wheel nuts. So this length, actually the one that has been specified here, should be as much as possible so that we can design this brace for a weaker person as well. So that sufficient moment arm can be generated. So here again, we have to specify the larger value for this handle. Then we have design for the minimum dimension, the second principle. This is just the opposite for designing for the maximum. So here a low percentile is chosen in determining the maximum height of a door latch, for example. So the limiting user here is the shorter user. So for example, the door latch must be no higher than the maximum vertical grip of a small person. So if a small person can reach the door latch, it won't be a problem for a taller person. So we have discussed this, the height of the seat example. The seat must be low enough so that a short person can rest the feet on the floor when using it. So if a short person can do it, the taller person can also do it. So the position of the door lock must not exceed the vertical reach of a small person. So this should be, for example, somewhere over here according to the, say, knuckle height. So the relevant anthropometric variable for this dimension of the product, that is the height of the door lock, might be the knuckle height. So the knuckle height of a shorter user in the population must be specified to decide the height of or the position of this lock. So say, for example, maybe fifth percentile value might be decided. So if a shorter person can reach the door lock, the taller person can also do that. So the limiting user is the shorter person. We have already discussed these two examples. So seat depth and seat height. So first of all, we have to identify the relevant anthropometric variables. So in the case of seat height, this would be the popliteal height of the people in that population. For this dimension, actually, that is actually the, uh, if we had a desk, for example, so that would be the desk height, the lower surface of the desk. So that must depend upon the knee height of the relevant users. But we are not discussing this height at the moment. So we are discussing just this seat height. So it depends upon the popliteal height. So we have related the dimension of the product with the dimension of the user, and then we have to decide the limiting user, that will be the shorter user. So we will specify a smaller value, say the fifth percentile value. And here in this case, the product dimension is the seat depth. So it depends upon this dimension of the user population. And here again, we have to decide this depth according to the shorter person. So actually it depends upon this dimension, that is from the back of the person to the back of the knee. So seat depth depends upon this dimension of the user population, and we have to specify this dimension for a shorter user, smaller percentile. And the final example is the top lid. So the screw top lids must be wide enough to provide a large contact area with the skin of the hand to provide adequate friction, and so that pressure hotspots are avoided, but they must not exceed the grip diameter of small person. So if a small person can grip this lid to open or close, then the larger person can also do it. Is there a rule of thumb? So yes, there is. There is a rule of thumb for these two principles, design for the maximum and design for the minimum. And that is, we have to look for the mismatch. And we have seen sufficient examples. So seat height, for example, would be according to the shorter user, because if we make it according to the taller user, it will be unsuitable for the shorter user. So mismatch was shorter user. So we decided the seat height according to the shorter user. And the door height, if we made it according to the shorter user, it would be a problem for the taller user. So mismatch there was the taller user. So we decided the height of the door according to the taller user. So we have to accommodate, or we have to address the mismatch, right? So which extreme will be suffering. So we will be designing the product according to that extreme. So specifically, space or fit is designed using upper percentiles. Again, the example is height of the door, width of the door, or width of the seat. And reach is designed using lower percentile. So seat height, the seat depth are the two examples that we discussed. So keep these in mind. So they work most of the time. So space or clearance or fit is designed according to the larger percentile value for heavier people, for the taller people, and reach is designed using lower percentile or shorter people. So this rule of thumb works in many situations. In the next segment, we will discuss the third principle, that is design for a range. Thank you very much.